There's life in the universe other than on the Earth? The answer is undoubtedly yes. But where?
There's no life on Mercury. It's scorched, wrinkled, and crater-scarred. Venus might have been Earth's twin, but it has a poisonous atmosphere, red-hot rocks, and pressures that would crush any life form to pulp. Mars, until quite recently, held out the promise of life. But now we know it's a sun-bleached, sterile world. The majestic giant Jupiter with its swirling weather systems and Saturn with its glorious rings are just balls of gas with no surfaces that life forms could live on. The outer three planets, Uranus, Neptune, and Pluto, roam our solar system's remotest depths. Far from the sun's warming rays, they're just too cold for life. And so it seems that our blue planet may be the only one in the solar system to harbor life. But astronomers don't give up easily. Out beyond the worlds of our solar system are millions upon millions of stars, other suns, which might have their own planets surrounding them. And maybe life?
One of the things that astronomers are very keen on these days, as you know, is are we alone? Do we have neighbors? What are the nearest neighbors to the solar system? And issues of that kind. It would certainly be quite fundamental if we make an observation which shows us the existence of our nearest neighbors.
In November 1974, a message was beamed from a radio telescope on Earth to a cluster of stars 24,000 light-years away. If any beings receive this message, they may come looking for the senders. But Earth has already had visitors from outer space.
A number of years ago, on a very cold December night, when the stars were just sparkling in the sky, no moon, I was returning from a trip in the mountains, and I'd arrived at a piece of the road where it went straight for about 25 miles. And all of a sudden, the roadway, the car just lit up, and I thought perhaps somebody had driven up behind me with their bright lights at first, and then I realized the light had illuminated the mountains about 25 miles east of me in the direction I was going. And at that moment, I looked up through the windshield, and right up here, probably the most brilliant meteorite I've ever seen across the sky.
Close encounters of a most unusual kind have been happening ever since the Earth was born. Meteors, and even more spectacular comets, regularly visit us from the depths of the solar system. They may tell us how we came to be here, and whether life may exist elsewhere in the universe. Some of these visitors come from a belt of rock and iron fragments between Mars and Jupiter. Others, the comets, lurk in the remote depths of space beyond the orbit of Pluto, unaltered remnants from our solar system's formation. Some comets get shifted from their icy perches and spend the rest of their days traveling through space on elongated orbits about the Sun. As As a comet is drawn inwards to the sun, its icy surface vaporizes, and the gases stream away in a tail which can stretch millions of miles in length. It's a comet's trademark. And we've just tweaked the tail of the most famous comet of all, Halley's Comet. The European space probe Giotto plunged into the comet in March 1986. Its TV camera revealed a comet's heart for the first time. A lump of rock and ice the size of Mont Blanc. Where it's warmed by the sun, jets of steam burst through from the comet's icy core. Like a cosmic chalk ice, the frozen interior is wrapped in a coating of mysterious black tar. Back on Earth, people saw the comet wax and wane as it swept past the sun on its 3,000th visit. This time, it passed a safe 40 million miles away from us, but we're not always so lucky. Some space debris ends up on a collision course with Earth. This was the ignominious end of a visitor from the asteroid belt, which ended its journey by crashing into a hillside in Siberia. Although not as pristine as a comet, meteorites like this are the oldest material in the solar system we can get our hands on. This was one of the biggest ever found. But every so often, a really big meteorite lands. And about 50,000 years ago, a 1 million ton chunk of iron came hurtling out of the sky and landed smack here in the heart of the Arizona desert. It blasted a hole 500 feet deep and almost a mile across. And the impact was so severe that we think most of the meteorite itself was completely vaporized on impact. The crater is so vast you can see it from space. Well, fortunately for us, impacts as big as this are pretty rare nowadays. And that's because meteorites, and indeed comets, are pretty rare as well. They're bits left over from when our solar system was born a very long time ago. But when a meteorite does land, it's great news for astronomers, because if they can pick up a meteorite, they can sample some of the first material which gave birth to the sun and planets a very, very long time ago. By analysing meteorites in microscopic detail and finding their exact age, scientists have revolutionised our ideas on how the sun and planets were born. We used to think that the birth of the planets was a chance event. A passing star pulled a filament of gas out of the sun, which later cooled to create the 9 worlds of our solar system. But the evidence from meteorites tells us that the planets came into being as a natural consequence of the sun's birth. 4.5 billion years ago, deep in a spiral arm of our Milky Way galaxy, a cloud of dust and gas began to collapse under its own gravity. As the collapse continued, the cloud spun faster and faster until it formed itself into a disk. At the center, where the gas was densest and hottest, our sun began to form. Further out, the dust particles form the beginnings, the cores of the planets. In the outermost regions of all, the gas was cool and slow-moving, and so these young planets were able to swathe themselves in huge atmospheres. The solar system, as we know it today, was taking shape. Meanwhile, at the heart of things, the sun was getting even denser and hotter. And one day, it burst into life. Nuclear fires ignited in its core, where they still burn to this very day. That first surge of energy blew away what remained of the gas cloud. All that was left were 9 planets and billions of tons of cosmic debris. Some of this rained down on the airless innermost planets, scarring them with craters of all shapes and sizes. Almost certainly that's how the sun and the planets were born. In fact, we're still seeing the last sequences in that story today. Debris still rains down onto the Earth. and comets zoom in from the outer parts of the solar system where the relics of the old gas clouds still stand. And when we look out beyond the solar system, we see that many newly born stars are surrounded by gas clouds of their own, very much like the one which must have surrounded the Sun in its early stages. Looking deep into space, we can see the past and future of our own Sun. Space is far from empty. All around are gas and dust, the raw materials from which stars can be born. We can see nurseries of infant stars and the dying remains of once mighty suns. Now we know that the planets of our solar system were born at the same time as the Sun, we start to wonder if other stars are born with planets too. But the mysteries of star birth are hidden from the gaze of ordinary telescopes within huge shrouds of dust. In 1983, a revolutionary astronomical instrument went into orbit about the Earth. ARAS was an infrared telescope in space, and it saw the universe in a new light. When ARAS looked at the great dust clouds in Orion, it could see through the dust to a cluster of giant stars being born within. In another dust cloud, it picked out the birth of a single star just like the Sun, but too far away to be able to see any detail. That had to wait until ARAS's infrared eye was turned on the brilliant star Vega.
And one of the most exciting discoveries by IRAS was, in fact, that stars, close stars like Vega and Beta Pictoris, actually have shells of material, disks of material in orbit around them. Material that might well be the building blocks of planets. The amount of material is fairly hard to pin down, but it's something around a few Earth masses, maybe as much as the mass of the planet Jupiter, in orbit around one of these stars. And we see a faintly glowing heat coming from this star that can only be explained by a shell of material like this.
So ARAS saw cool matter around Vega, but it didn't look like our idea of a solar system. ARAS, however, had seen several similar stars, and two astronomers took a closer look at one, Beta Pictoris.
Brad Smith and I decided to follow up on the IRAS result of material around other stars. We used an ordinary telescope and some rather sophisticated ground-based instrumentation to look at Beta Pictoris, one of the IRAS stars, and found it was surrounded by a disk of material, flattened disk indicating the material was in orbit around the star, something like 10 or 20 times larger in extent than our own solar system.
This is the first picture of a solar system beyond our own. By blocking out the glare from the central star, they were able to see the faint glow of its disk, seen edge-on. But what was it made of?
Ice is almost certainly the composition. There may be some rocky material mixed in with it, but it's almost certainly ice. And it is, in fact, almost certainly the very same material that was around the Sun 4.5 billion years ago when the planetary system formed.
You're trying to say it's a solar system in formation?
We are, in fact, saying that it is a solar system, either in formation or actually perhaps already formed. In other words, what we may be seeing is the debris that's left over after the formation of a planetary system around Beta Pictoris.
So there could be planets in there as well?
Yes, there's no direct evidence at this moment one way or the other, except to say that when you have that much material, it's almost impossible to conceive of planets not forming. So the probability, although we can't detect them, is very high that Beta Pictoris is surrounded by planets, and then what we see is this big disk of leftover material that didn't get into the planet formation.
Beta Pictoris is a star which in many ways is very like our Sun. What's the possibility of finding these kinds of things around other stars?
Yes, I think that's what's so particularly interesting about this discovery. When we start thinking about the possibilities of life elsewhere in the galaxy, in the universe, the question is our own solar system unique? Is it very rare to find a star with planets around it? And we had no idea whatsoever what the answer was to that question. Now we have found another rather nearby star with a disk around it which almost certainly indicates planetary formation. And if there's such a disk around Beta Pictoris, there are undoubtedly many other stars as well, and that would say that star formation or planetary formation go together, and that planets may be very, very common throughout the galaxy. If planets are common, then the possibility of life is very much increased, and it says that there's probably a very good chance that we're not alone in the universe.
It's a long way, though, from seeing a disk of matter around a star to finding an actual planet, a place on which life might exist. The problem is that a planet is small and dark, and it's almost impossible to spot against the dazzling glare of its sun. But astronomers are a resourceful breed. By using infrared, they can turn down the contrast between a planet and its star. At Kitt Peak Observatory in Arizona, astronomers have equipped one of the largest telescopes with an infrared detector. For years, they've been trying to pick out planets circling the nearest stars in space. And finally, with a faint star unromantically named VB8, they think they've succeeded. For the first time, man may have discovered a planet around another star, and the man is Don McCarthy.
Well, I saw two objects that were close together, about an arcsecond apart, and differing in brightness by a factor of 20 or so in the infrared. VB8 is thought to be one of the lowest possible luminosity stars, right at the limit of what a star is. And so finding another object that close and yet 20 times fainter than VB8 already indicates that the two are physically associated and that the fainter object can't be a star.
Don's infrared camera scanned across the star VB8 in two directions. In both directions, it showed a second blip. It had to be a planet, and it was given an even less romantic name than its sun.
Well, we call it VB8b.
That's boring. Couldn't you come up with something a bit better than that?
I have received a lot of letters from school children all over the country who have very interesting names proposed. Hesperios and Vulcan, and some names have already been used.
Vulcan's a good one.
That's right.
Our own planet, Jupiter, bears many resemblances to VB8b. Both generate their own heat because they're so very massive. It's this telltale heat which allowed the infrared camera to track down VB8b. But we know that planets like these can't support life. Do you hope eventually that you'll find planets like the Earth around other stars?
Well, that's the hope, but it's very difficult to directly detect the light from an Earth-like planet, because there you're not seeing its heat so much as its reflected light. And an Earth-like planet is very small and would not reflect much light. So I think in the immediate future our goals are to detect the heat from larger planets. And the search for Earth-like planets can be accomplished by doing more of the astrometric measurements, where you're not looking at the planet itself, but the motion of the star that gives away the planet. And that's possible from space, too.
But the search for a planet of any size circling another star is still going on, because since we talked to Don, it's been revealed that VB8b isn't real. It was nothing more than a reflection in his camera. And despite many false alarms since, no one has found another planet out there. However, we've only just started to look, and in time, our search must surely bear fruit. One day, we may find a whole set of planets orbiting a star, and the future astronomer who explores them will be like Goldilocks, looking for one that's not too big, not too small, not too hot, and not too cold, but just right. With air and sea and land, and maybe life. And of course, the question on everybody's lips, if planets are common throughout the galaxy, what about you and me? What about life?
Well, there's a very large string of factors that go together to arriving at us sitting in this room talking about life or life in other solar systems. The first thing you have to have are lots of stars. We know there are lots of stars, so that's one good thing. The second thing you need to know, are there lots of planets? Then you need to know, are the planets in the right place to have the right temperature? If they have the right temperature, do they have water? And a whole string of things finally leading up to, if there's an imperfect environment for life, does life form there and does it become intelligent? I think we can now make a good case for saying that planets are common around other stars. What will be left to another satellite or to other observations is to push on to those other questions that eventually lead you to the conclusion that, in fact, life is a common thing. And I don't think we know enough yet. That's still in the realm almost of theology rather than pure scientific fact.
If life has developed somewhere out there, what's it like? Will it have evolved along the same lines as creatures on Earth? Or might it be even weirder?
Jeremy, we've got all sorts of weird life on this planet. If there are planets in plenty out there, would you expect to find something like this on them?
I would, yes. I mean, if you're going to get life, it's probably going to follow certain rules. And if you've got plants for harnessing the energy of their sun, whatever it is, then you're going to get big things like elephants and other things like that to eat the plants. So, yes, I would expect something a bit like an elephant.
What about these really weird things that science fiction authors tell us exist, like sort of 16-foot-high tripods?
Well, that's a little more doubtful. I think those are really a bit too imaginative. You see, the thing is that I suspect that wherever you're going to get life, it's going to be based on, probably on carbon atoms to store the information and build up the life molecules, and on liquid water. Yeah. And I don't think that's going to enable you to build metallic-looking tripods, you know, that wander around the countryside laying waste to it.
The next intriguing question is how far life on other worlds might have developed. We think of ourselves as pretty advanced creatures, but in astronomical terms, the human race are mere babes. Many of the stars were born long before our sun, and so any inhabitants of their planets will be much more mature. Our idea of a space-age city might seem quaint and primitive to an alien. But if there is advanced life out there, it's not giving itself away. From time to time, radio telescopes search the skies for any hint of signals from alien civilizations. So far, they've drawn a blank.
The irony is that we probably broadcast more about our existence to them than they have to us. Ever since we started transmitting radio and television programs, our radio signals have been leaking away, albeit weakly, into space. And traveling at the speed of light, those very first radio broadcasts made in the 1920s have now reached stars 60 light-years away. And within that radius, that includes literally thousands of stars. And if there really are inhabitants around the very nearest stars, equipped with extremely powerful receivers, they'll be picking up this program too, in 4 years' time.
On one occasion, we deliberately broadcast our existence from the giant Arecibo telescope to the universe at large. The message, pulsed in binary code, showed our number system, the chemicals of life, what we look like, and where we come from. Sounds simple, but it needed an IQ of 200 to decipher it. And some people reckoned we were just asking for trouble. The intelligent aliens who received the message might not be friendly.
Controversial though the Arecibo message was, we've actually been even bolder in advertising our existence. The two Voyager space probes, which are destined eventually to leave our solar system, both carry very detailed information about our whereabouts.
They reveal exactly where to find us in the galaxy. There's another plaque on the Pioneer spacecraft, already on its way to the stars. But alien eyes might find this part of the diagram rather difficult to interpret. We've also sent a long-playing record into space, together with a stylus and instructions. These interstellar calling cards won't reach even the nearest stars and their possible inhabitants for 40,000 years. And we naturally expect that they will be falling over themselves to pay us a visit.
And maybe that says it all. We arrogantly assume we'll be recognized, respected, and acknowledged wherever we go. But in truth, where does human life figure in the pecking order of life in the universe? When I look up at the night sky, I can see thousands of stars. Through a telescope, I can see millions more. All of them are suns like our own, and most of them probably have planets. But those planets are no more obvious or important than moths swarming around the lights of a distant city. And yet, many of them may harbor life itself. On some of them, life may be as brief in its period of living and as transitory as a moth itself. But on others, life may have endured and be prospering.
You can keep an eye on the